Last time we talked briefly about the various strategies for doing arithmetic with fractions: addition, subtraction, multiplication, and division. But we didn't get a chance to do a lot of examples. We were just doing one sort of open-ended problem solving. So let's get into a little bit more of the weeds of that. Let's suppose that I wanted to carry out this arithmetic in part C. Multiply negative 14/5 times 2/3. First of all, let's take negative 14/5 and rewrite it. According to the discussion that we just had, if I want to see this as a single fraction with a integer in the numerator and the denominator, what should I do with negative 14/5? What should I do with this negative sign, I guess is what I'm asking. Yeah, let's elevate it. Let's put it up into the numerator. Let's stick it on the 14. Again, only on the 14, not also on the 5, because then that fraction would become positive, which it wasn't. So bring that negative upstairs. Okay, great. So now this becomes simply a problem of multiplying these two fractions. So how do we multiply two fractions? We can just multiply straight across. Multiply numerator by numerator, multiply denominator by denominator. That's the great news about multiplication, is that it is the simplest operation to do with fractions. We don't have to modify the fractions at all. We don't need a common denominator. We don't need to flip anything. We don't have to worry. We can just multiply straight across. Depending on how recently you've done a lot of fraction arithmetic, some authors will talk about like cross-reducing and doing all kinds of other stuff when you multiply. My personal feeling is don't bother, particularly when the numbers are relatively small, like they are here and like they will be for us most of the semester. Just multiply directly across and then worry about simplifying the fraction afterwards if any simplification is needed. So I'll get negative 28 upstairs, I'll get 15 downstairs, just from multiplying straight across.
Is the numerator negative because the bigger number?
How do I know that the number in the numerator should be negative 28? Where did this negative 28 come from?
Because the negative is attached to the 14.
Yeah, exactly. It came from multiplying a negative times the positive. Next question is the fraction negative 28 over 15 being written as simply as possible? Or is there a simpler way to write the fraction negative 28 over 15? The question of whether or not a fraction is written in its simplest form is really the same as the question, is there a number which both evenly divides into 15, but also evenly divides into 28? If there is such a number, then we can use that number to reduce this fraction into lower terms. So a valid question, and one that you'll do some asking of when you work on practice problems, is what are the numbers that go into 28 and 15 evenly? Let's start with 15. How can I multiply two numbers together and give me 15? 3 and 5. Really, that's the only option that's interesting, right? The only other option is 1 and 15, and 1 is not very interesting as a way of trying to make fractions smaller, right? So 3 and 5. How about negative 28? Or let's forget the negative. Let's just talk about 28. So 4 and 7, yeah. And what about 4? Because 4 can also be broken down further. 2 and 2. But then once we hit 2 and 2, now we can't break that down any further. What do we call these kinds of numbers that cannot be broken down?
Prime.
They're prime numbers, exactly. So what we've just constructed here is the prime factorization of these two numbers. This is going to be an especially important topic for us later in the course. When we start talking about factoring in more generality, this is the sort of second half of the course topic. We're going to be doing this not just with numbers, but we're also going to do it with algebraic expressions later on in the semester. But for now, we can look at these prime factors and say, well, there's nothing, 2, 2, and 7, that goes into negative 28 that also goes into 15. Right? So there's nothing in common, as you said, which means that we are done. We can just put a box around it and make that our solution. Going back to your original point about mixed numbers, if we wanted to, and we don't, but if we wanted to, we could rewrite this as a mixed number. And without getting into the weeds on that process, Let me just do that. So that would be -1 and 13/15. Right. And yet another reason that mixed numbers are irritating is that if we follow that same process to turn it back into a fraction by multiplying this and then adding 13, we're not going to get the right answer. Because it turns out that that hidden arithmetic in the middle would mean that instead of adding 13, we would actually have needed to subtract 13 from our product. Yeah, so mixed numbers are just bad news all around. Let's just enter in our answer here, -28/15. Again, I just use the minus sign for negative and the slash for fraction. I'm just going to choose to submit answer. And we'll see what it does with it. So actually, that's interesting. So we entered -28/15, and the system itself turned it into that mixed number, -1 and 13/15. I don't know why it does that, but it accepted our answer anyway. So the safe path is always use an improper fraction. Don't even worry about mixed numbers. There may be a problem now and then that asks you to consume a mixed number, but never worry about reporting mixed numbers. You can always write as your answer, particularly on quizzes and anything that you write on paper. Always use improper fractions for that. It covers all your bases.